Alright, this lesson today is all about modeling and solving one-step equations.
John McIver to the front office, please.
Sorry about that, you guys. This you saw yesterday, right? So this was the legend we built at the end of the day yesterday. Yesterday, positives were red, and yesterday, negatives were blue, right? With the actual kind of models he showed. So we're doing the same kind of thing here. First up, oh, I'm sorry, you guys. First up, let's go through a couple together here. So let's just talk about what this is showing. We're gonna write the equation that is modeled below. So we got to check our key here. This thing is a negative x, and then we've got 4 of these, right? And because they're all reds, because they're all filled in, we're going to call that positive 4. We're going to say it's plus 4 or it's positive 4. And we're kind of using the plus and the positive to mean the same thing here. Now, all of that is equal to negative 1. Our goal later on is always going to be to figure out x. Some of you might be able to look at this and see that right now. We call that inspection, when you can just kind of look at the diagram and figure out what's going on. So in this case, if we stick in a negative 5 here, it all works out. Right? So x would actually be equal to negative 5 in this case. But all that comes later. We're going to be building up to that today, and that's one way to do it, is actually just to look at it and see if it all works out. So pause the video here for a minute, and then try 2, 3, and 4. I really want you to work through those on your own before you watch the video so you can see what's going on. So pause it here, try. Alright, hopefully you've tried these for yourself, you guys. I really feel that's important. And here's the next one then. So hopefully you're checking your legend every time, right? You're starting to remember what's going on in the legend. X is equal to negative 5 on this one. And we need the equal sign in there as well, right? Don't forget about this little guy, because we're modeling the whole equation. We're not just modeling a piece and a piece, we're modeling something equal to something else. Down here we have a negative x, and another negative x, and another negative x. So you might have kind of thought about it like that, or you might have thought about it like 3 times negative x. But the way this is usually written is just negative 3x, right? So this is what we have over here. We have negative 3x. I'm going to come back to that in a minute, because in this example, the 3 directly in front of the x has a name. And if you remember that name, that's awesome. We talked about it a couple days ago. It's a numerical coefficient. So write that in, please. You're going to hear that again and again. We're going to be talking about a coefficient. Numerical coefficient. Okay. Now we've got to figure out what this negative 3x is equal to, and it's equal to negative 6. So any way to think about it is good, but I'd like you to write this one down, because this is the way you would actually see this. Right? And we talked earlier about how when side by side, that means multiply. Right on. Last one, number 4 here. We've got 3 on the right, and they're filled in, so they're positive.
And Amy DC come to the office, please. So Kubert and Amy DC come to the office, please.
Sorry about that. So that 3 is equal to half of x. They're showing you 1x right here. Oh, that should be negative. This would be a whole x, a whole negative x, but it's white. So the whole thing we've got over there is x over 2. Okay? Awesome. We're not worried about what the x is equal for all of them just now. We just want those 4 things. So make sure you've got 1, 2, 3, 4, and you know. Pause the video again if you need to. Now we're drawing diagrams. So take a minute here again. Pause the video and draw your diagrams. See if you can do it. Alright, now that we're back, here's what's going on. We've got x plus 1, 2, 3, 4, 5 equals 7. 1, 2, 3, 4, 5, 6, 7. Now, in this one, we've got 2x. Your diagram should look something like this. Equals negative 8. and we're using the blue, or we're using the whites. And the last one, we've got a positive x, red or filled in. Now again, this is minus 3.
To the following students, please come to the front office. Hannah Fair, Chelsea Munson, Caitlin McGuire, Roddy McDonald, and Brooke Carter.
3, 4, 5. So this is important, right? We can't show minus 3. We have to show the negative stuff. Okay, check and make sure your drawings look just like those. Check 5, 6, 7. Pause it if you need to, and then we'll move on. All right, here we go. An opposite operation undoes another operation. Examples of operation are subtraction, addition, multiplication, division. You may sometimes hear opposite operations called inverse operations. So here's our rule. To undo an operation, and again, we're talking about multiply, divide, add, subtract. We're going to do the opposite. So make sure you've got that written down. To undo an operation, do the opposite. That's important. I also want you to make a note of this. Whatever you do to one side, of an equation, do to the other. And you'll see why that's important down here in the next step. Again, we're all about getting the x by itself. We're all about solving for x. So whatever you do to one side of the equation, you have to do to the other. All right? So down here, again, what we're all about, it says solve the following equations. We're going to use our rule. There's our rule. We're also going to, we want to get x by itself. Now I'm going to do one and let you try the last couple. So we're going to do d together. And we always got to think about what's happening to x right now. Right now, or this isn't x, this is a d, sorry. Right now, d is being divided by negative 5. So to undo, we're going to multiply. So d divided by negative 5, and we're going to multiply by negative 5. Now we've got to think about this too. We have to multiply the other side by the negative 5 as well. Alright, so here's what's going to happen. I'm going to put in a couple extra steps for you here, just so you can see the math. We're actually doing this. With fractions, this is actually what's happening. This side's just going to equal negative 60. That's all good. But now we've got d divided by 5, and then we're timesing by 5. So we'd actually have negative 5 d's on the top and negative 5 on the bottom, right? Negative 5 times d is negative 5d. Negative 5 times 1 is negative 5. So negative 5 d's divided by negative 5 d's is just d. So all the way down. Sorry about that, guys. We're in the end, we've just got d by itself. All right, that's important. Try the next two. Pause the video. Try 9 and 10, then we'll go over them together. So you should be doing them, you guys. You're not going to learn this if you haven't done them yet. So you can still pause it and do them. If you've done them, here you go. We're undoing that operation. We're dividing by 3. And we get x equals negative 15 divided by 3. X equals negative 5. It's not just 5, it's negative 5. Over here, we're undoing that operation. The negative 4's cancel, just like they canceled right over here. Same kind of thing going on over here. So negative 20 divided by negative 4 is 5. 5 equals A. Now, you'll have to remember, this is kind of something we talked about a while ago, that a positive times a positive equals a positive. A negative times a negative equals a positive. And a positive times a negative equals a negative. A negative times a positive equals a negative, right? So these ones we have same sign, always equals a positive. Here we have different signs, equals negative. So you may want to write that down for yourself if you're getting confused by those. You also want to make sure you've got these answers and you did the math and you worked it through. If you've done that, your assignment on this stuff is actually on the board, but it's check your understanding. Section 8.1, and you're going to choose 7 questions. Thanks, guys.